In this video, we are going to enable auto-healing for our Cloudron service using HTTP Startup Probe and HTTP Liveness Probe. Basically, auto-healing is an ability that automatically makes your service up and running properly from deadlock and non-functionals by killing malfunctioning service instance and start a new one. Sounds interesting, right? How do we do that? It's very simple. We only need to configure a HTTP Liveness Probe, and with the help of HTTP Startup Probe for our service. First, let's take a look at the definition of Startup Probe and Liveness Probe. Startup Probe is used to determine when a container is started and is ready to accept the traffic. In the meanwhile, Liveness Probe is used to determine when to restart a container. By default, if we don't configure a Startup Probe ourselves, TCP Startup Probe will be used. So TCP Startup Probe is automatically configured with the default value for Cloudron service if we don't configure a Startup Probe yourself. How do we confirm that? So we should know that Cloudron have two CPU allocation modes. The first one is CPU only allocated during the request processing. It's also the default one. And the second one is CPU always allocated. So by default, we are running with allocated CPU during request processing, and CPU only allocated during a container startup, serving a request, and shutdown. So how do Cloudron know that it's finished its startup state and moves to a service state? Yes, by Startup Probe. When Startup Probe checks successfully, then Cloudron moves to a service state, and in this stage, no CPU will be allocated if there's no request coming. Look at the current log. We have Cloudron service and log. Okay, we now try to restart it. Just keep everything remain the same, and then check the log again. So new instance start. And then okay, here we can see that Stormcast started on port 8080. So the TCP Startup Probe will be successful after this line. When the Stormcast server starts, it's enough for TCP checking, and then no CPU is allocated after that line. So by this, your service is supposed to be up and running, but it's not right? Because our service is up and running is actually after this line, when the service notified that yes, we started the application. So we haven't seen it clearly in this example, so I will make an update to our current service to we see that clearly. Back to our service. So we will create a component class. I will name it catch initializer and implement application listener with refresh, contact refresh event, then element method. So in this event, I will try to log something. So first let's add a component and logging for this one. Okay, so in this one, for example, we will simulate a loading catch here. So catch loading, then so simulate that time unit dot second dot sleep for 15 seconds. For loading failed, catch load failed. And log info catch successfully loaded. Then let's run it again. So now we can see that before Tomcat server started successfully here, we have to wait for our application loading cache before the application is actually be ready and up and running. So let's put this one, simulate catch loading, and push it. Okay, let's deploy a new code into Cloudron and see what happens. So actions, I will deploy a new one, float. Now our Cloudron deployed successfully. Let's take a look at its log. So this is the new code. And we can see that the Stormcast started on port 00. And the TCP check will successfully after this line. And this means there is no CPU allocated after that. So now we can only see cache loading. But actually after this one, there's no CPU allocated. So your application is not really ready. It's not ready yet. So this means that the default TCP startup probe is not the correct one, and we have to change to the HTTP startup probe. So that is also one reason that we should using the HTTP startup probe, since there's no CPU allocated. So if we want to have CPU for this process, we have to call the request into this instance. So for easily, I will call by using this link, but before that we have to here, to that here. Okay, now I can use this link. Then I will run it, and we'll take a look at the log. So we now have a request processing. Okay, let's create a new instance. It returns successfully. I want to see some log. So there are requests coming. So now CPU is allocated. Let's do it some more. Run, reload it 3 or 4 times. So the CPU allocated, and then we see, cache is successfully loaded, and the application is started after that. So as we can see here, we can confirm that we have a full CPU allocated during a startup state, and after that, in the serving stage, there's no CPU allocated. So we have to wait for a request to have CPUs, and then if one instant stay for more than 50 minutes, it will be shut down, and in the shutdown stage, CPU also allocated. Set up a startup probe here. So this liveness probe. This is an HTTP start probe. So to do that, we have a startup probe here. The level equal to images. So have a startup probe. Then in Cloudron, have to YAMLify this one. Edit it. Image. The level equal, right? Image startup probe. Yes. Container startup probe here. So we need a path for health checks. Luckily we have that one. So it's a card service health. Not that one. Where's that? Actuator health. Okay. Actuator health. Because we have our actuator dependency here, we already add the actuator dependency here, so I think this one should okay. So we can use this one. We can use this one. This one. So we don't need header. And delay initial seconds. So based on the reverse run, we know that our application needs at least 30 seconds to run. 30 seconds file run. Sorry. Log here. No. List needs 30 seconds to run, so we will wait for 30 seconds. Okay, do this again. Okay, no, please copy it. Okay, it's how to move to here, and so we should wait around 30 seconds, and we'll set up the timeout second is 1, the period second 5, failure. So it will first run the startup probe at 30 seconds, and after that it will, if the first one is failed, then it will run 10 times, and by the gap time is 5 seconds. So after 5 seconds, it will run 1 time, and it still failed. So is to wait for 5 seconds and then run one time and wait for 5 seconds and run one time until 10 times. Okay, you guys still read the documentation here. So this threshold is number of time just try to run and period, so the period of time. Okay, then we have 30 seconds. Let's run it. So we need to rename 32 save the live. Then take a look at the log. So now we have this one here. So we have at least 30 seconds for startup checking, and CPU is allocated during that time. Then if we look at the log again, so like, yeah, new instance start, and in the first 30 seconds CPU is always allocated, and then we can load in cache, and now in 15 seconds we still have CPU for successfully load the cache and application started. Yeah. I don't know why it's shut down right after, but yeah, it's the idea for using HTTP startup instead of the default TCP startup probe. And then last one, let's configure the liveness probe as well. Liveness probe. So the HTTP liveness probe is similar startup probe. So copy it. Then we'll jump files and edit the same level with the image. So I'll paste here. Liveness probe. The path is the same. I'll copy this one. Don't have initial. So initial output 0 in this time, and timeout, because liveness probe is triggered after startup probe successfully. So I think after startup probe successfully, we can right away check the liveness probe and don't have to wait for anything. The timeouts I'll put here 1 second, failureThreshold 3 and periodSeconds. So we have 30 seconds to ensure our instance is up and running. 10 multiplied by 3, 30 seconds. Okay, then before live. Okay, take a look at it. The same, we have the timeout here, the failureThreshold and periodSeconds. This period, yeah. Okay, back to here and check that. Okay, we have log. Take a log. See. Okay. And then if we see here, we could see that we now successfully configure the liveness probe and the startup probe. Okay, thank you for watching. See you in the next video.